Well, thanks. What I'm mainly going to do is talk to you about some of the, I retired 6 years ago, and I'm going to talk about one of my research projects I was pretty excited about at the time, and I focused on fire and climate. And in that, we'll touch on many different aspects of other things, fuels, fire policy, and others. And I'll be around during lunch if you have some questions, and after this session too. Hopefully I'll change some of your perspectives as you see here some of the paradoxes that there are in the fire world. And that's not just pair of dogs. You're almost dog. Okay, so we were focused on regional fire years. So what in the US Northern Rockies, so Idaho and Montana west of the Continental Divide, what determined what are the years of really widespread fires? Well done. Thanks, Michael. Of course. And why this topic? These are the fires, the years in which we have so much fire, there's not enough people to go around. There's not enough money to go around. And people have to prioritize, kind of triage, what are they going to do and where? And most of the area that burns during the regional fire years, which means that they burn under relatively extreme conditions. And why here? Idaho has had so many extensive fires, and this part of Montana, that it has shaped fire policy and fire management. There's a lot of things managers have just, we don't have any choice, we're going to try this new thing. Okay, and then there. We were trying to look at fire history over time. And so we, low severity fires, we looked at the fire record that's in stumps and logs. And I'm passing around this section. Don't mind if this comes off, it's a piece of the bark. That happened this morning. I would have glued it on. And just so you know what you're looking at, did we skip one? I think so. Yeah, so when a fire comes along, you know, the tree's growing, and a fire damages it from one side, that's the red, is the dead tissue, and then like us, it heals. And so we can date those scars, you know, and if the tree's growing along and then another fire comes, you get another fire scar, and you can date those and see how often fires happened in the past. And we specifically went to the elders of the world, the snags and logs. We didn't have to cut into only one living tree in this project. And we were interested in taking small cross sections like that or thinner, and then we could cross date them. So that's kind of like a barcode on a grocery store item. You can look at the pattern of the wide and narrow rings and use that to say what exactly, even if it's a dead tree, when did that fire scar actually happen? And if you look at it under a microscope, after you've sanded it off a lot finer than that, you can also say, did it happen early in the year? Did it happen, you know, when in the growing season that ring represents, did it happen early in the growing season, late, or maybe in the dormant season? And we were targeting points because we were really interested in understanding. We have one of the longest record we would have possible. We got some that went back before 1650, but we didn't have enough sample size, and that's partly because things burn up. It wasn't that the fires didn't happen before 1650. There were plenty of scars out there, trees that won't survive, and it went up until 1900. And that's because after 1900, they started getting more suppression, a little bit, grazing, roads, other things, and there just weren't as many fire-scarred trees. And we, in this large area, we would say, okay, a regional fire year is when you had more than 25% of all the sites we sampled had fires. So it wasn't one fire burning all of those. It was that in a regional fire, you get lots of years, lots of fires in lots of places, all at more or less the same time. Didn't go up far enough into the future. So we said, okay, well, what's the next history? And so we found good records in maps, mostly from national forest lands, So most of this project doesn't really speak to what happens on non-federal lands. It doesn't speak to what goes on outside of forests. But it can speak to those. And so 30 million acres within the black outline. So these are the forest boundaries, and the gray areas are what burned over that time period. Pretty impressive, huh? And then we kind of like we had done with the fire scar record, we were interested in seeing what are the regional fire years. So what we took the years of most extensive fires, and they turned out to be about 10%, 11 out of the 104-year record that we had, which went from 1900 to 2003. These have been updated, and you can sometimes find them online, but you can definitely find satellite records. And so after this time period, most of it has been from satellite records from the starting in roughly 1980s, 1984. So here's regional fire years. I know it's too small for you to read, but just if this is the shape of Idaho. Have you ever noticed how the shape of Idaho is like Richard Nixon's profile? Okay, you can see that. And then you can see the black areas, the areas that burned. So this is Idaho and that part of Montana that's west of the Continental Divide. And then the black is areas that burned according to those fire atlases. And they were reconstructed. They were people who just did handwritten maps, and then they were eventually digitized. So they're imperfect, but they're the best record that we could get. The 1910 fires, somebody's already mentioned these, the years of, it was really extensive fires that helped shape what the Forest Service did. It gave them a mission of protecting fires. And so it really started fire suppression with the Weeks Act that happened right after that. So what do you see here? This is, I'm interested in if you see the pattern I see. So this is the tree ring record, so the past. This is the 20th century, the Atlas data. The circles are the years of more extensive fires. So the bigger the circle, the more fire scars, more sites were scarred that we found. Or here in the maps, it was the area burned. And then this is dry down here to wet in the summer. So this is summer moisture, wet and dry, and this is spring temperature, cool to warm. What do you see as the pattern? And is it the same? Hot and dry. I told my mom that, she was not impressed. She was like, really? They gave you a lot of money to study that. Wow, I'm really, yeah. But what was
proud of you, kid.
What was different about it is that we tied it to warm springs. So it's not just the summer moisture, it's the warm springs, and we're getting warmer and warmer springs. So and we got regional fire years when we had both a warm summer following a warm spring. So the warm spring would help set up it would dry out not just the south facing slopes, but the north facing slopes, not just the low elevations, but the high elevations. So things were set up if you got ignition and you got wind. They were set up to have extensive fires. And just to look at that data a little bit differently, this is the graph from 1900 to 2000. The red are the regional fire years. And probably the most important thing that you can hopefully see even from the back, this is the area burned, is there's almost none in the middle. Mid-century, a long time without fires. And it's not that fires didn't happen, they just weren't big or in lots of places. And this is against the summer moisture and the spring temperature. This is the average. So again, this is warm springs and dry summers. And we found that that gap was probably fire suppression got really good at that, partly because we had funded it and we'd organized it. We were ready to go after 1935. There was a 10 a.m. policy that said, we will have, if you don't get the fire out by 10 a.m., then you have to get it out by 10 a.m. the next day. And we'll throw whatever resources we need at it to do that. And if you haven't made it out by 10 a.m. that day, then you better sure have a plan to do it by the next day. That policy stayed in place for a really, really long time. We just sort of added to it by having some, so what some people call let burn or other prescribed burning kinds of things. But think about what happened in that time period. It was much easier for suppression to be effective, and fuels must have really accumulated. And then it got warm, and we had a lot of, and this is the 88 fires in Yellowstone, and covered a large area in Montana as well. So the 20th century fire suppression really, it did lead to fuel buildup, so that when fires happened, they had more negative effects. Fires weren't happening as often, and we talk a lot about area burn has increased. When you look at it, if you just cut the graph here and only looked at it here, you think, whoa, yeah, big problems. A different perspective, I think, is useful. If you look at the fire return interval of vegetation types, we would have expected 45 to 105 million acres a year to burn in the West. And just to put that in, this is on the top of your handout. It was about 9 million acres burned last year. So a lot more burned historically. In fact, probably 5 to 8 times as much burned historically as we're currently experiencing. And we live in a fire environment where fires are going to happen, and we're going to have more of them in the future because climate is changing. Let me explain why we think that. Basically, it's well, I'll do that the next slide. The other thing we're seeing is that the fire season has gotten much longer. So in Idaho, at least 32 days longer since 1984. In Western US, 84 days longer since the 1970s. And that's what this graph is. This is, fires, temperature, spring, snowmelt. And this graph here is the bottom of it is the last time any fire was not detected in a season. And this is when the first one was. And so that gap has gotten larger and larger. And it's because we're seeing more warm springs and more warm dry summers. And so if you look at the vulnerability, these people have updated their work since this was published in 2006, but it's a great graphic to look at. They said, okay, if we look at climate models, what's going on, and we look at fuels and other perspectives, and they primarily use climate. They said, look at what the Northern Rockies is going to be especially vulnerable. We've always had a lot of fires in the Northern Rockies, the US Northern Rockies. And of course, there is more Northern Rockies north of us, but we didn't have those records. I sat next to a Canadian today and he was like, US Northern Rockies, or US Northern Rockies.
You can't say Northern Rockies. I was thinking up by the Yukon somewhere.
Thanks, Bert. And then I'm a fire ecologist, so I'm really interested not just how big fires get. I want to know what effect they have and what that implies for recovery. And so burn severity is a measure of that, and often you can compare like in a satellite image, or you can do it on the ground. What did it look like before and then after the fires? And you see a great amount of change, as in high burn severity is generally classed as 70% or more of the trees burned in a spot. Low is less than 20%. And it turns out that lots of the area within burn parameters doesn't burn with high severity. Most of it burns with low or moderate, and lots of unburned islands. That doesn't get mapped when they map a fire perimeter. So it makes a huge difference to pay attention to what they're saying. And so I spent a lot of time trying to ask that question of why, when, and where do large severe fires occur? What are their effects? And what causes them? And just some highlights. The patchiness really matters. And if you've missed a lot of fires, you're gonna likely have, or if you're in really extreme conditions, you're likely to have bigger patches. Where if it burns under relatively more moderate conditions, or maybe not so long since the previous fire, you're likely to have more patches, smaller patches. And those make a huge difference in the rate of recovery, because if there's a seed source close by, if there's if they tend to be a little bit more moderate in their climate, then that makes a huge difference in the rate of vegetation recovery, whether it's from the seed in the trees. I studied mostly the surface, what happened to the wildflowers, what happened to the shrubs, what happened to the grasses, what happened to the underground soil. And so most of the landscape did not burn with high severity. The unburned, or the refugia, some people call those because they're refuges, only 7 to 10%, they covered 7 to 10% of even these really big fires that happen in regional fire years. And only 13% burned with high severity. That was a bunch of fires. And yet this is a burn severity atlas that was actually from New Mexico. So what about the future? What I learned from this is fires are going to happen. We live in a fiery environment. And not only that, we want them to happen. Because if we start letting fire fuels accumulate on the landscape, what kind of fire are we going to have in the future? May not all be high severity, but it's certainly going to be harder to stop, probably, if that's what your goal is. And it might threaten a lot of things. What happens in the regional fire years, we have a lot less stream flow. If it's hot and dry in terms of the fuels, it's really not too good for the fish that are trying to make it through that year and depend on cold water, like trout, in the streams that don't have very much water in them because it's dry. So there's a lot of other things that go on in that. But we live in a fire environment, we should expect them. Fires have always happened, and they are part of the personality of the forest. There's something that happens. It's a really important disturbance. And what happens to all that biomass? Most of the time it doesn't break down, decompose. So it just accumulates until fire comes along. Climate has been and will be conducive, but we're also, with this growing wildland urban interface, having many more people and their homes in the path of fires and closer to fires. And that's a challenge. Says on here, I don't remember what the 10% of the West land areas, it's now, they were expecting, that was in, let's see, Idaho, WUI, the wildland urban interface increased by 72% from 1990 to 2010, even more now. And so in some areas, not just in Idaho, but west-wide, it's likely to be 40% of the land area. And that's a really important, because that's where we spend most of our money when we put firefighters at risk, protecting homes, taxpayer expense for private land. Who knows what'll happen this year? But certainly it is costly. And I would hope that we could manage for more positive and less negative effects. I'm not watching the clock anymore.
I'm not either.
I'm getting close. So when I think about fire management challenges, it's really how do we, there is an ecological reality that fires will happen. There's an ecological imperative that many of the things we want from our landscapes depend on fire. That's true for a lot of plants. It's true for a lot of animals. It's true for, so fire affects wildlife habitat, bird habitat, and other things. And how do we find out, how do we manage the ecological realities, imperatives, with balancing the need to protect people and property? And you have to be strategic. I'm a big proponent of using prescribed fire or other kinds of innovative fire management. I don't like using the word innovative with prescribed fire because it's something that humans have always done. One of my favorite sayings about fire is that fire is a good servant and a bad master. So if we use him, and if we use it in a way that's innovative, strategic, creative, practical, we're going to be paying attention to using it as a servant, whether that's during fire as part of the suppression process, whether it's the most fire effects are changed if it's not been long, if it's burned fairly recently. And I think we also need to be thinking post-fire, not only about rehabilitation, but we should be celebrating, and we should be planning for the next fire, because every post-fire is prior to the next fire. Okay. Thanks, getting close. You're in center of one of the leading fire programs in the country, in the world. We have educated a lot of leaders that are out there in the world. I just pulled this picture out of, this is in 2007. Those guys are all fire leaders in one way or another, except for Scott. He went into EMT and paramedic. Helped my son when he was in a really nasty accident. And we saw each other and it was like, I know you. So people go on from this program into many different kinds of things, whether they come for an undergraduate. We now have a 2-year program in fire, which is great for people who just want to, I just want to go out there. I just want to go out there and I want to know enough to be better. Or you can do a bachelor's degree. We were the first place to have a bachelor's degree in fire in the US. You can get lots of graduate degrees, and certainly our research is distinctive. And I had 19 before, then I went down to 12. It was like, how many? I don't know how many faculty we have, but a lot of them doing really innovative and effective research and outreach. I want to thank all of the collaborators. There were a lot of students that helped me shape my ideas. A lot of fire managers. I've spent a lot of time out and about talking to people and learning what they learned from their experience locally. And I think we need to value that. That's really important. And then certainly a lot of research collaborators who helped me with these various projects. I think that's it.
Yeah, thank you.